Again, I'm revising up the things. We discussed the line chart, right? How we can make even the double points over there. We discussed how we can label your graph, how you can make grids. We saw some mathematical things like the sine graph, the cosine graph, the simple markers, and the line plottings. And then we saw some line styles, line width, right? Some logarithmic graphs, how we make it there. The bar chart we saw, right? Then we'll be needing this data yesterday also, right? We saw some of the bar things, right? We made one data, small data. Then some of the thing, right? We introduced the strip plot yesterday. We'll be going much into detail. Horizontal bar plottings, the figures we discussed, the subplots we discussed, and the grids we discussed, right? The things. Now today we'll be starting up with the pie plot, okay, and then we'll be going up with those histograms and all those things, okay. Fine, and in the Seaborn we'll be going in the later onwards, right? So first going things from here, okay. So before going to this, let's just control. Bring 1 minute. In the matplotlib, we discuss the things, plottings, okay. And Seaborn, we have to discuss this all. Okay, fine. Leave it. So the very first thing is the pie plot. Okay. Now, what is a pie plot? What we say in what is a pie chart? Yes, describe quickly. What's a pie chart? Answer. What is a pie chart? We have been dealing with the pie charts, right? From class 7th, you would be seeing up the pie charts. Even you would be making up those things in some sort of samples. What is a pie chart? Quickly, guys. It's an easy question.
It is something which represents, I mean, like, let's say which region, what has happened. So, different representation can be there in that same graph, same chart, sorry.
Okay, so it represents a region. Yes.
Yeah.
Okay. So what bar graph does then? Distribution of the data on the basis of the weightage of the elements. Okay, yeah, exactly correct. And in a circular statistical graph, right? So pie chart is like a circular statistical graph, which is, as you say, which gives you a distribution of your data on the basis of the weightage of the elements in the numerical proportions, and it is divided into the slices, bar plots compared to variables, yeah, obviously. Okay, so that's the thing basically, right? So we are going to discuss the pie chart, right? We are going to just see that how pie chart works. So let's bring this data, what we discussed yesterday. Okay, let's import all the things. Alright. Now quickly let's see a plotting. So if I say that I just want to plot a pie graph, that says I am going to write plt.py, that's it, right? So pie plot of what? Let's say I want to plot a pie graph of the deaths. I'm getting a graph. I've got a graph, right? But no proportions, no labelings, nothing has been there, right? So I'll have to make labels accordingly to my needs, right? Or I will have to make it there accordingly. So this spy function, what I'm writing it here, the spy function, this plots a single data range only, okay? So it will calculate the share of the individual elements of the data range being plotted in whole of the data set, you can say, or whole of the data range, you can say, right? So that is how it does basically. Okay, so whenever you define the pie chart, it is a type of a graph which is a circle. It is divided in some sectors or some slices that represent a proportion of the whole uh, community, not exactly the community, you can say, well, the whole data or the whole set, things like that. Okay, so that's we are getting up just a plotting of that. Okay, now these are the points that has been taken up, right? Now we can give labels to this. Now for giving labels, we'll have to write the labels equals to whatever you want, right? So let's say the labels going to be as labels as states. X, STATS. It's fine. Okay. I'm defining. It's a variable. Okay, so here's the label also, right? But still, in what proportions these has been taken up, we are not getting that. For giving the proportions, or like the percentage, we'll be using a formatted slice percentages to the slice, or to the pie graph. So to view the percentage of a share in a pie chart, you need to add an argument that is called as autopacity. Okay, and that's with a even with a format of a string. So it will show the percent share of each slice what you are getting up here, right? As the whole or formatted in some certain manners. So we are going to use the autopacity. Okay, that is an argument basically. So autopacity, or you can say it's a kind of a formula. So what you write over there will be presented accordingly. Okay, so the percent of each value is like calculated as the single value divided by the sum of all values and then by the 100. Okay, so like we'll be giving the format of printing our percentage should be like percent 1 point, let's say for 2f. Okay, percentage. So I can see the percent after percent, the 2 points. Like if you want one value, you can make it there and you can see in one side. Okay. Now with this whole thing, like I can see my graph to be very compressed off, right? So what I'm going to do, I'm going to make it quite large as by giving a figure size to this. It's looking quite large and I can see clearly the things. So Karnataka, Andhra Pradesh and all sorts of things over there accordingly. Like, so I find this not as a good color. So I'm going to change the colors basically, right? So for changing the colors, what can I do is I can write a column like colors list over there. You can say accordingly the colors. Let's say orange. Okay, and 1, 2, 3, 4, 5, 6, 7, 8. Fine. Now here I will be giving the colors to be color. That's it. And after plotting, I'm going to save this figure as uh, deaths in the COVID dot the JPG. Run this and okay, again I have written the JPG. That's in the COVID dot the PNG. So I could see a graph particularly there and the things, right? The graph, and also that has been saved there. I'm saying if let's go with, you can see the graph, the shares and all. Okay, blue is not looking good up there. Let's make it as white. Yep, nice. Okay, so that's how we go in the plottings, pie plot. Okay, subplot we have seen yesterday, how we can subplot the things, right? You know, we have seen yesterday how we can subplot. I think that's easy. Any doubts in the subplot yesterday one? Yeah, anyone having any doubts in the subplots? What we did yesterday? If you have doubts in the yesterday sessions, you can ask, right? Because we'll be going into later. Let's download. Okay. This is yesterday one. Let's close this. So 10/9/2003. This is 2 yesterday ones. Okay. Fine. Now, so subplot was creating a plot within a plot, or like in some axis, 1, 2, or 3 kind of things, right? Accordingly, like if I say plt dot plot, if I make you remember the plotting subplots. Say subplots, then what this defines, if I write 1 to 1, what that define, guys? Yes, answer quick. What is 1 to 1?
The subplot contains one row, two columns, and the subplotter on the first position.
Nice. Good. So this will be plotting range of 12. And now the subplot of 1 to 2. And I write face color equals yellow. Now you'll understand what yesterday we discussed, right? Face color, edge color, and all those things. Now we'll see it. Face color has no property. Axis is having no property of face color. Okay. Okay, I have written wrong spelling. Yeah, okay, fine. So what you can see, the face color over there as yellow, and the plottings basically. So this is plotting the data of just 1, 2, and 3, right? So plotting 1, 2, and 3, subplots of 1, 2, 1, and then plotting range of 1, 2. I think it's no need of this, right? So plotting the range of 1, 2, that is 12. So range of things from 0 to 11. That's the first one. The second one is the range of 1 to 12, and that's you can see the heights of this is going given like quite better from this. The right side of 15. Let's see the things accordingly, right? That is the face color basically, giving like a yellow one. Now if I write this here, the like we discussed the face color and we discussed the edge color. If I write edge color, let's say spelling mistakes, right? That's nice. Okay, right. Okay, okay. I'm in the wrong place. This is wrong. Edge color is there. X tag dot remove X box v type of Y campus. Okay, fine, we'll see it. Right. So problems within line that is working or something. Okay, fine. That should be right. So that is like we saw how we plot the things one to like adding a subplot, removing something from there, making it that kind of that, right? So if we again like discuss, like we have the figure and axis, or let's say it as A. So with the two rows and the two columns, we are going to subplot. Now let's say my x is equals to a range of 15.
So could you once again explain the pie chart? Actually, I had little network issue here, so I could not see the pie chart code.
Okay, we'll go it once. Let me complete this. We'll go with that. So what we can see if we are making a figure, a subplot of 2 cross 2, that means 2 rows and 2 columns, obviously. There we have 2 rows, 1 and 2, right? And then 2 columns, 1 and 2. This is 1 and 2, 2 rows, 2 columns, okay? And now first axis, the 0 of 0. So what is my a of 0? If I say a of 0, so a of 0 is the whole thing, right? This a of 0 is this whole 1. If I say a of 1, this will be the below graph of this 2. This 2. So similar, I want the a of 0. That means for this first one, I'm plotting x with x squared, and that's a square graph basically. And I have given the title as square. Similarly, if I say a of 0 to 0, plotting x with the sine of x. Okay, sorry, this would be 0 of 1. See, sine graph will be something like this, right? So according, like if this is a square, let's make it as a square root. Let it be a sine one. That's nice. And let's copy this now. We'll be doing it for 2 times for the rest 2. So this would be the 1 of 0, and just changing of the things. This would be the cos. And this would be the tan. And let's plot this. So you're going to find square, sine, cos, and tan respectively. And why to make a square? Then let's make it as so all the values of this particular subplotting. I think that's clear, right? So to make a subplot, you can make it accordingly. Yeah, Anshu was having doubt in the subplots. Sorry, in the pipe. What doubt you are having? Anshu asked.
I missed this pie chart only fully because of the network issue.
Okay, see, what we did is like we plotted data of this deaths, what we have declared, like what we have initialized and like mentioned over the data in the deaths. So we are plotting the deaths, okay, and then we are giving the slices what we are getting. We are giving the labels to this with the states data what we have, and that is being displayed over there, okay. And then we made an autopacity, right? That's a basically argument that gives you the percent share and the state how you want. If you write 2f, that is 2 float point after the decimal, you'll be getting 2f there, okay. That's an autopacity. And how it is being calculated, that is uh, the values, how it is getting calculated, the single value divided by the sum of all values, and then it multiplies with the 100, okay. And the colors have defined the respective colors, 8 colors, to be given accordingly to each of the states. I've defined with that, and then I'm saving this as a kind of a PNG, and this is making it enlarge, and that's all how things works, okay.
Okay.
Yeah. So getting up ahead in this matplotlib. Next we have the, like we have discussed the squares and all. Like if we go in the yesterday things, we have discussed the squares, the values of all the things, right? If I make you see again that graphics. Let's say from 0. like this, right? Sine graph and the cos graphs and all those things, like with the sine lens and all. Okay, I think that is clear. Whatever we have discussed yesterday, pie plots and all those things will be clear, right? So now we are going to see like the bar graphs also we have seen it, right? Okay. Now let's create a bar graph even more to see it better. Like now we are going to see the taking it up with a real life example. Right? So 0, 0, 1 and 1. And now let's say that I'm going to make some technologies. I'll be defining some technologies going in like nowadays. So whatever it is going, I'll be writing up there. So data science, so like AI, cyber security. What next is like big data is also a trending one. One more, what is there? DevOps. Okay, so like these are the technologies that has been trending for now. You can see, and the learners could be like in the data science. We could say around like if we go with a percent share of 100, I will say 40% with the data science, 30%. Like I'm giving just a share of this values. Like how percentage I would be giving it there. Okay, and I want a bar plot of this specifically. So bar of technologies versus the learners. And the color, let's say I'm making it as gray. Sorry, it's very dark. And in the bar graph, I'm saying the width of all the bars to be 0.75. Clear as no attribute of add. So I could see a graph where data science has been leading, then followed by the cybersecurity, big data, DevOps, and things accordingly. Right, so that's a bar plot basically. So similar to this, I can make even the histograms also. So what is a histogram kind of thing? Like let me go to the Seaborn. Where it is, where it is. I think it's, yeah. Okay, so we'll go in deeper with the C1 now. Let me give you an introduction of what exactly is a C1. Right. So this is a Python data visualization package or a library kind of thing you can say based on Matplotlib. Okay, this is based on the Matplotlib and it gives you a high-level interface for drawing attractive or statistical graphs, as you can see up there written. Right. Uh, some common features to this is like you can go for aggregate statistics, you can go for specializing your categorical values or variables, you can go for seeing the unvariate and the bivariate data, you can go with various themes and color palettes, right? And you can just easily what to say, you can easily do the plottings or the close integrated with the pandas data structures, right? What we say, if we just go with a common understanding, what is HTML? Anyone? What is HTML? What's the full form of HTML?
Hypertext markup language.
Yes. So, like, if we say CSS, that's an upgradation of HTML version, right? That's HTML used for the static pages and CSS for like giving you just a like what to say, a styling or whatever we do with the themes and all customization, we could say it better. So customizing your website, CSS would work better, right, as compared to HTML. So like that, we are talking about the Seaborn is kind of a customization in your Matplotlib. Okay, right. So we'll be going in that in detail, but before that, let's go to see the histogram. Right. Okay. What is a histogram? hmm What is histogram? D1. What is histogram?
It, it's it's a plot for continuous variable and just for one variable.
Plot for one variable. That's how.
Continuous.
Okay. So continuous plotting of one variable. Okay, fine. So, like, if I have a bit of data in a histogram, so it is going to plot only one variable. You're saying like that, right? So, like defining when you define a histogram, that's a representation basically, or unique demonstration or unique distribution of any numerical data, right? And we would be seeing it in like the Seaborn as a kernel density estimation, and a lot of things would be there, right? So let's complete the matplotlib very soon. Okay. So let's take that I have bins now. What are bins? Anyone? What are bins?
Interval.
hmm Interval, class, right?
Yes.
Exactly. Correct. So I have defined my intervals now, and I'm going to make it a bigger size. And that's a histogram. So let it be giving a histogram of some data I'll be plotting up with this bins. Okay, that's the syntax I'm thinking. And then you can write the histogram type, a bar or kind of thing. I wouldn't like a bar. And the width to be 0.8. Okay, now let's define something. Let's say that we have a bit of data, right? So some values. Let's say we have population and their ages. Okay, so I'll be writing the population. Let's say 22, 55, 62, 45. And let's run this invalid. Oops. So that's a histogram basically in a bar type. What if I remove this? Still in the bar type, right? But when we go in the XS type of this, plotting the same thing, but within XS type. Okay. So let's say how exactly a histogram. This is not a bar one exactly, right? If you see the bar graph, this looks like this, right? This is not a bar. This is in histogram exactly. But what if, right? 1 minute. Okay, fine. Yeah. So let's say if I define my figure in XS and I say it to be a subplot, one, that's it, one row, one column, and I'm plotting a histogram of this population age versus the learners, right? And the bins has been given up. Okay, over one distribution, one will say. So if I go with this population age only, and I declare with the bins, like go with the bins, right? And let's run this. So you'll be getting the data accordingly. Like you're seeing the things here as like in a separated way, but here the things will be a closely packed things. That's it, right? Basically, that's a histogram, exactly like that, right? Because in the bar graph, every ticks will be having its own values, right? See, data science. Anytime, whenever we go with the bar graph, I'll make you see one more bar graph. Who is that? Got it, my point. Right. So in a bar graph, more data will be there. Like let's say if I say plt dot a bar graph, okay. So this is like 0.25, 1.25, going with the intervals of 0.25. So label, let's say I'm going to give you label of like any mg hectare. Okay. And the width of the bars to be 0.5. That's it. Similar to this, I'll plotting a bar where now I'll be giving my intervals like things as 7.5. Okay, and here let's say the data has to be any good car name. Okay, I'll let it be a car name. Right? So if I say plot the legend, I can see the graph basically, right? Giving MG active and SUV. But what's like plotting, you can see this but like a bar graph, multi-bar graph, when you say of, right? Like for giving it a more descriptive, making it more descriptive, we can write the title, that is the like a bit of raw information, and we could say it's X label as the days, right? And Y label as the distance in kilometers. So now it's like a descriptive one, right? So we are going to see the basically the days the cars has been going on with the distance in the kilometers. So on the 0th day, like if you want to set your ticks, we can set that, right? And we'll be looking on that how we can set the ticks and all in any graph when we say the values. Like in place of this 1, 2, 3, we can write Monday, Tuesday, Wednesday, Thursday, and Friday. That's like setting the text values and the text labels. That is called as like that. Okay. All right. Moving up next. So coming to the seaborne one, like okay, coming to the seaborne type. So in the seaborne, the very first thing we are going to discuss is the unvariate and bivariate things. Okay. So what is very times we say it as univariate, bivariate. What is that basically? So when we say univariate or bivariate, that is working with a one dimension data, two dimension data, more than one dimension or one dimension. Okay. When you work on a single data, when you plot a graph with a single data, that is an univariate or unvariate, you say. And we go with more than one thing, that is a multivariate, bivariate, basically. Okay. So like in Seaborn guys, we go to understand like when we deal with the Seaborn, there are several things to be focused. Why? Because in Seaborn we have a lot of data sets which we can use for our plottings. Okay, a lot of data sets are there. For example, if we want to see in a Seaborn what a lot of data sets we are having up, so we can easily write the dataset names to be plotted up, basically, right? So, like you can say, get underscore of dataset names. That's it. So, wait a minute. Yeah. So, these are the dataset names. The datasets we can directly download from the Seaborn without any internet, right? You don't need the internet over there. So these are the free data sets which comes with the inbuilt of the Seaborn, so that you can work easily up there. Okay. Wait a minute. Let's see the trial. right? So these are the data sets what you could have there to work on with it, right? So how you deal it, like for loading any data set, when you want to load from the Seaborn, what we do is we write, let's say we are loading the iris data set, right? So what do we say that if this is iris data set, like DF of iris, what do we say? Like in the pandas, we read it like pd dot read underscore and all. Here we'll be reading it as sns dot load underscore of data set. And you don't have to write any format like CSV and Excel and all. You just write iris. That's it. It will be loaded up. And now I'll be giving you sample of 3 data sets. So getting up that, right, that you're having the sepal length, sepal width, petal width, and the species in this data set specifically. So even if you don't have this data set in your PC, like laptop, so you can just directly download it from there and you can get it, right? So these are the columns basically having this data set. What are the columns? Sepal length, petal width, and all, right? So what are the species? So we have 50, 50, 50 and all, right? So the very first thing is in the Seaborn is the count plot. You can see a count plot that shows the count of the observations, right? So if I write SNS dot count plot of this species, so you have to give the parameters. I want to plot the species and my data is iris. Okay, a T is missing. So I get the colors descriptive thing of a graph. It says the center size 50, vesicolors is 50, virginica is 50. Similar to this, if I bring some another data, let's say for Titanic, so like in the Titanic data set, we have survived, P class, their sex, their age, their siblings or spouses if they're having, the parents and the children's, the fare, the embarked, where from there we have from where they have embarked up, their classes, and then they again the sex like named as who. So these are the columns which are of no use basically, right? From here again the adult or like false of them. So obviously like we can mention it from there, right? Okay. So deck, embark down, alive and alone, right? So from here, like if you want to see what were the number of people, passengers exactly who survived, right? So we can write SNS dot count plot. We say the people who the passenger who survived and the data is going to be TF of Titanic. That's it. So 1 is the survival, 0 is not survival. So 300 plus only survived and 500 plus didn't survive. So that's the first question. Okay, next question. We plot the graph showing the number of female and male survival, right? So female and male survivor, how we can go? We can write a count plot of the survival based on their, so labeling, that is use semantic, right? So label or categorized by their sex. The data is still the paginate. So we could see here that 1 is the orange one for the female who survived, the 0 orange is for the female who didn't survive, and accordingly, like, okay. So we could find that over 200 plus females survived and over only 100 males survived, right? Now, next question. So over their classes, that is like first class, second class, and the third class, we could say on the basis of their class. Third class male didn't survive a lot. So we could find that the first class, not for the males and all we are talking, like exactly this is the number of males basically, like combination of males and females here, okay. So we find that the first class people survived much as compared to the second class. Then we see the third class people also survived much as compared to the second class, right? Okay, so that's been the ratio of survival. So also we'll see the okay. So number of males and females in the data set, how we can write SNS dot count plot, and we could say we want to plot the sex on the basis of their classes. And we can write the data to be Titanic, like hope this come first, right? So we see a lot, like if you see the graph still, right? So we can find the first class male and the first class female. That's what here we have seen. The survive 0 and 1. It's quite same, not exactly, but quite similar, right? If you see the two graphs, these are not exactly the same, but quite similar. So we can say that the number of males were around 100 in the first class. Female were less. The number of males in the second class were much higher than the female. And the number of third class males were also much high because these were the only people who were running the ships, right? Making contributions a lot in the ship, and they also died even a lot, right? So, like this, we can go with the conclusions and like finding out the things accordingly. So, if you want to see like what were the number of the people who survived in the third class, right? Survival according to the class we have seen up there. Well, like exact data if you want to see, so we can say DF of this Titanic, and we want to find the DF of Titanic, and in the survived. Okay, let's take only with this one now. So here you want to see in the survival where the people have survived. How many people have survived, and then also you want to see not survived. Class belongs to third class. Invalid syntax. Titanic. Okay. What is it? Okay. Okay. Fine. So we can find a list of something over there. So let's see. So 119 only survived. How many traveled? 3, it's like, okay, I got understood. That's because of the inheritance. 491 traveled and 119 survived. How many there was, apart from this, how many were from the male? Then more if we. Let's see. Oh, 47. 47. How many males travels exactly? Three 47. 300 were gone. 300 died. Oh god. Oh no. 300 people died. Like, see the ratio 47 out of 347. Oh. So like you can go with the things. We will be going tomorrow with more, right? So this was only for the count plot. How we can go for the count plottings and all that. There is a lot of plotting basically. Scatter plot, bar chart, point plot, box plot, violent plot. Lot are here also. Regression plot, joint plot, pair plot, map, facet grid, LM plot, rel plot, reg plot. A lot of things are there. We'll be going in the thing, right? Okay.